Well, today we will resume transformation of exponential function, or generally speaking, exponential function. But today we'll put a heavy emphasis on sketching graphs of transformation of exponential function. In the previous lesson, we did look at one example on transformation. Today, I will go a little bit more detail into other examples of transformation of exponential function. Just a recap, an exponential function is any function of x that can be written in the form y equal a to the x, where a is positive. And if you were to sketch either one of those, there are two shape of exponential function. A to the x, if a is greater than 1, then the graph is increasing. The y-intercept is at 1, and there is a horizontal asymptote y equals 0. The domain would be all the real numbers, and the range is from greater than or equal to 0. If a is between 0 and 1, for example, y equal half of the power 3, then the graph is a decreasing graph. In other words, as you go towards, as x increases, y decreases. And in this, that's the basic difference between the two. Otherwise, the range is the same, the domain is the same, and the y-intercept here would be 1, 0, 1, same as over here, 0, 1. So the y-intercepts are the same, the range is the same, the domain is the same, the horizontal asymptote is also the same, except that it's a decreasing graph for where a is between 0 and 1. If a is greater than 1, the graph is increasing. So a basic y equal to a into x graph is a graph that intercepts at 0, 1. Now, if these graphs could be transformed, if you have a transformation of the graph, it could shift to the right, shift to the left. If we shift down or we shift up, it also could be compressed or stretched or compressed horizontally as well as vertically. In the previous example, we looked at graphs where we sketched them. Now, today we'll extend that. And so if we have a graph and y equal a to the x, the image of it is y minus k, or it could be written as, I'll show you that, equals c a d to the x minus h, where a is greater than 0. Now, this is your vertical translation. So the k, if it's written this way, the vertical translation would be, in this case, plus k, going up. If it's plus here, that means it's going down, x number of units. The horizontal translation is through h. So if we were to write this out, this is your horizontal translation. This would be your vertical translation. The c would be referred to as your vertical stretch by a factor of c. So if you have c in here, it's a vertical stretch. If it's greater than 1, you have a stretch. If it's between 0 and 1, you have a compression. This is your vertical stretch. So vertical stretch. This is your horizontal stretch by a factor of 1 over d. It's similar to what we did in the unit and transformation. So if you have a graph y equal a to the x, which is a general graph, For example, if you go back to our example here, and we have a horizontal translation, this graph will then switch to y is equal to a into x minus, let's say 2, translated 2 units to the right. This will move 1, 2 units. So now this becomes 2, 1. So this would be a similar graph. The shape will be the same, except it shifts to the right. Now, if you want to shift upwards now, we can plus 3 here, and this will go up 3 units. 1, 2, 3. Now this graph now will be 2, be what? This is 1, 2, 3, 4. So it's, remember, it's from where y equal a to the x. So that's your horizontal and vertical translation. Now, if you have a compression now, or a stretch, that will be the number in front of the a, which is your c. So you go back to here. So this is your c, vertical stretch, and your d is is your horizontal stretch or compression. Now, let's look at this translation. If I have this graph y equals 2 to the x, now I can transform that graph with in this case, we have a shift, a vertical shift upwards, 4 units. This is your k, 4 units up. Then you have a horizontal shift, 3 units to the right. Notice the c is 1, so there is no compression. It's the same as before. If this was 2, then you have a stretch. If it's a fraction, you have a compression. The d is 1, so there's no horizontal compression or stretch. So if you were to look at a sketch, here I have a graph y is equal to 2 to the x. If I were to transfer that into 2 to the x. Now, if I were to shift this graph up 5 units, I'm going to plus 4, because I'm going up by 4 here. So here is, sorry, there's 0, 1 here. The 0, 1 goes up 4 units from there. On the other hand, if I were to have a horizontal shift of 3, now I already shifted up here 4 units. This would be my 0, 1. This is my original graph. And I shifted 4 units up. Now, by the way, this is my new horizontal asymptote here would be y equals 4. Always 1 unit below the y-intercept. Now, this I shift 3 units to the right, so I go 1, 2, 3, and this would be 3, 5. So here, my horizontal asymptote is still 3. So the question they ask, when you're given a translation, it'll always ask you to refer to the y equal a to the x. Now, the y equal a to the x, you can strip it down. Now, this would be my, if I were to rewrite this as 2x minus 3 plus 4, another way of writing it. Now, if I were to remove this, remove it, I'm left with y is equal to 2 to the x. So this will be the graph you'll use to find your x and y coordinates. And then, once you find the x and y coordinates for 2 to the x, you're given this translation, you would transfer it into this corresponding transformation, which would be x over d plus h, cy plus k. So once we know our x and y for 2 to the x, we can make that translation. I will go through a few examples to show you how this works. So always you're given, and we'll look at a couple of examples that you're given, and then you have to transform that. Now, for example, I will be given example 10. We are given y is equal to 2 to the power x plus 1, and we are asked to transform this graph. I'll show you how we'll narrow this down into to the x graph first, and then we'll make the transformation. So before I go on to these, let's go to other questions that are much simpler for us. We look at some other transformation, and then we will go on to transformation. Let's look at some basic graphs here. Yes, sir. So in this example, you were given y equal 5 to the x. And I've created a table of values. And for any one of these questions, a table of values is critical for you to use, because it helps you in your sketching. Now let's look at this example. You have y is equal to 5x. And if you can almost speculate right away, based on what we know about exponential function, that this would be an increasing graph. Because if you go back to what we know, y is a to the x. If a is greater than 1, we know this graph is increasing. The asymptote, if there's no transformation, there's no horizontal or vertical shift or compression, horizontal or vertical compression, then this graph is increasing, and the asymptote will be y equals 0. Your intercept will be 1, y-intercept, and your range would be all of the real numbers, and domain will be greater. Sorry, and the range would be greater than or equal to 0. Sorry, greater than 0. So let's look at the first example. 7a. Graph each exponential function below, determine whether the function is increasing or decreasing, intercepts, equation of the asymptotes, domain and range. First of all, we create a table of values. And generally, you'll select values between -2 and 3, or -2 and +2. And here my tables, I have x on one side, and I say my y is 5 to the power x. So we're going to walk through each of these here. So when we have x is -2, y would be 5 to -2, which is 1/25, or 1/5 squared. So first point is -2, 1/25. So if we got here, it was that's your point. Next, we have x is -1, 5 to -1, which is 1/5. So -1, 1/5, which is about very almost touching it. And 5x is 0, which is 1. Five to the 1, when x is 1, y is 5. So we can go 1, 5 is up here. 5 to the power 2, which is 25. So 225, which would be way up here. Well, this is way beyond my scale. So 5 to the power 3, which should give me 125. Which is way beyond my scale. So I can sketch this graph by connecting the smooth line here. Y is equal to 5x. Now, look what happens here. We have where a is between 0 and 1. So negative, so 1/4, negative 2, which is 1 over 1/4 to the power 2, which gives me 1 over 1 over 16, which works out to be 16. Because 1 divided by 1 over 16 is equal to 1 multiplied by 16 over 1. Next we have, so first point, negative 2, 16, which is way up here. We have 1/4 to negative 1, which is 1 over 1/4, which is 1 divided by 1/4, which is equal to 1 multiplied by 4, which is equal to 4. So negative 1, 4. To the power 0, which is 1. Quarter to the power 1 is a quarter. So when x is 1, y is a, and so give us 1/16. So sorry. So this is my y equal to 1. Now the question asked, is this graph, so this graph is increasing you can see the graph is increasing because as s increases, y increases. As x increases, y increases. So there's no x-intercepts. And the y-intercept equals 1 or 0, 1. Horizontal asymptote. Yes, we know there is one horizontal asymptote. Is equal to, oh, I should say y is equal to 0. So all this means that the graph approaches where y is equal to 0 but never touches it, right? And the domain x set of real numbers and the range y is greater than 0. Now, if we compare a y to the 1 quarter power x graph, this graph is decreasing. Because as x increases, y decreasing. I'll put this up a little bit neater. Same as the other one, there's no x-intercept. Y-intercept 1. Horizontal asymptote. Y equals 0. Domain x set of real numbers and the range y is greater than 0. So here we have our standard exponential graph. There's no transformation. I'll show you one where it's decreasing, the other one is increasing. Now let's look at a transformation graph. And this is question 10. This can be found in the textbook. And this is where we will be using our transformation rule here in this question. Okay, so take this in mind. I'll refer to it frequently. So as I mentioned to you in the example we started off, let's put this away here for now. So use transformation to sketch a graph of each function below. Determine the function is increasing or decreasing. Want to know if it's the intercept, the equation of the asymptote, the domain range. Now, in many ways, you can say, okay, I already know what this function looks like. It's an exponential function, is increasing. You can go from there. But this is transform. So if you look at this question carefully now, this original graph y is equal to 2 to the x is being transformed, because if we were to strip the transformation, what this means, this is my k. It's 1 unit vertical translation, 1 unit up. This is your horizontal translation, which is 1 over 2. So we have a horizontal translation, horizontal compression. So it's horizontal compression. We have a vertical translation, but there's no horizontal translation. So recall from our previous, we're going to compare this. We compare this with y minus k equals c a. Now, this is where our original x minus h graph. Now, our a in this case is 2, so I can translate that. So I can make this y minus k equals c2 dx minus h. I can rewrite this as y minus 1 equals 2 to 2x. Okay, I'll put it over here so it makes sense. Y minus k. I can put this right under here now. It becomes y minus, in this case, is 1. Minus 1 is equal to, now my c here is 1. 2. Now my d, 2 into x minus 0. There's no translation, horizontal translation, but the, in this case, the vertical compression is 1. It doesn't change. The same, there's no compression. That means if there's a 1 there, there's no compression. If there's a 1 here, there is no horizontal compression. But in this case, there's a 2 there. So the horizontal compression will be 1 over 2. So let's translate that. So the image of this graph, right, is y is equal to 2 to the x. So, or I should say, the image of this graph is y minus 2 to the x. And I arrive at this graph by stripping away the translation, the vertical translation, 1, and the horizontal compression of 2, or 1 over 2. So we can transfer this now. We can say that our vertical translation is equal to 1. And our horizontal compression equals 1 over 2. So we can conclude that k is equal to 1, d is equal to 1 over 2. We have our h is equal to 0, and our c is equal to 1. These are the things we need. Because we also learn that any transformation, you have transform x and y, and this would be like where y equals, in this case, 2 to the power of x. We find our x and y value. And whatever x we have here, we substitute it into this corresponding transformation, x over d plus h. So that will be your x coordinates for your transformation, and your y coordinate is whatever you have for c, you multiply by your y value plus your k. So let's look at that now. And here we have it. And I've recorded here in a chart. So what I've done ahead of time, I've created a chart. Y equal 2 to the x. Now this is my given function. And that's a transformation function. To sketch it, I need to find the x and y coordinates. And based on our general corresponding transformation, x over d plus h. So I transfer that to my x over d plus h, cy plus k. And here are my values. 2 to the x, remember, I derive it from my original transformation. So I remove any kind of transformation here. The compression and the translation I remove. If I remove these, I'm left with y is equal to 2 to the x. And that's why I have 2 to the x. So this is my original graph. So it's like if I were to construct y equal to 2 to the x, it's a graph that will go through here for sure. And we'll sketch it first. So let's find y equal 2 to the x first. And whatever we have, we will take our x and y values and transfer them here. Now, what I've written x over d plus a, this is what we know. And cy plus k. Now, x over d. Now, x over d would be, oh, sorry, d is here is 1. This is 2, sorry, d is 2. Because that's what you get here. Correction, so d is 2. Just jumping the gun by putting it, your compression is 1 over d, which is 1 over 2. But I haven't done that. So now I substitute the values into my given corresponding translation. Now, when there's no h, so we have x over 2 plus 0, so that's why I'm left with x over 2, because h is 0. Remember that. Okay. Now, c is 1, so 1 times y, and k is 1. That's why now I can simplify to x over 2 as my x value coordinates. And I'm going to put away here x and y for my. So let's work this through now. Now, 2 to the x gives me 2 to the negative 2, which is 1 over 4. I'm going to sketch this graph first. And here we have negative 2 is a quarter. It's about here. 2 to the negative 1 is a half. 2 to the 0 is equal to 1, which I could have predicted before. Two to the 1 is equal to 2. So 1, 2, 2 to 2 power, give me 4. Oh, I have one more here, 3. 2 to the power 3 is equal to 8. Because you're doubling, so 3 to the 8 would be up here. So this would be my sketch for the graph y is equal to 2 power x. That's my sketch. Now, just remember where I got this from. I got this from the function, transform function, and I strip away any transformation. And the hint of it is that you will look at your a value and remove everything else and keep the x. And that's your original, that would be your original graph, if you were to call it that sort. Now we have a transform graph. We take the value given for x, in this case would be negative 2. So negative 2 over 2, which gives me, I'll write it over here, negative 2 over 2, which is negative 1. So one negative 1 here. And my y value would be 1 times y. The y is a quarter. So a quarter plus 1, which is 1.25. So that's my first point. So -2. So x is -1, y is 1.25. So what we have there, -1, 1.25 would be about here. Then the next one, we have x is -1, so -1/2. Remember, I'm using x and your d value. The d is, in this case, or we already established it here, which is -1/2. So -1/2 is my x coordinate point. My y coordinate now would be, what's my y value here? It's 1/2 plus 1, which is 1.5. So -1/2, 1.5, which is slightly above, so it's about here. Then we have x is 0, so 0 divided by 2, and that will give us 0. And we have 1 plus 1 gives us 2. X is 0, y is 2. Notice we have a vertical translation of 1, so you could have predicted it's going from 0, 1, move up 1 unit, so your y-intercept here would be 0, 2, because you're moving up, shifting 1 unit upwards from our original equation. Now let's continue. We have x 1/2, so now we have x coordinate of 1/2. And the y coordinate would be 2 plus 1, because it is y plus 1. Y is 2, gives me 3. This is 0.5, 3, so 0.5 and 3 up here. Next one, we have 2/2, which is 1. And our x now would be 4 plus 1. Which will give us 5. X is 1, y is 5 here. Okay, let's try, since I have one more. So we have 3/2, which is 1.5. And you have x plus 1 is 9, so 1.5, 9. So 1.59 is my next word. 1.59, which is up here. So now I'm going to connect. So now this is my graph. So now I connect all these points here. I draw it correctly. And this is the graph that's been transformed. So now, what do we find here? Is we know this function is increasing. Because as x increases, y increases. The intercept, where it's at equal at 2, so the y-intercept equals 2. Domain and range will be the same, and what we have the horizontal asymptote now, our horizontal asymptote, oops, I overset my bound here. My horizontal asymptote would be this guy here. So the graph never touches, so y equals 1. Because we shifted up, and it will give you, this will give you a hint. Your vertical shift will tell you your horizontal asymptote. So if it's 1, the horizontal asymptote is always the unit below that. If it's a part, is in this case, it's not a reflection. If it's a reflection, now you will change. We'll look at the reflection. The graph is reflected later on. And the domain and the range would be domain. It's a set of real numbers, and the range. Now the range where y is greater than 1. Be careful, because that's your horizontal. Look at your horizontal asymptote. That's a. Be careful with your horizontal asymptote. Because everything originally, the horizontal asymptote here is y equals 0. Now, because it's shifting vertically up by 1 unit, therefore your horizontal asymptote also shift 1 unit from 0 to 1. Okay, we look at one final example, and this one is a little bit more. It's more to this question, where you're asked to sketch a graph using the graph y equal 2 to the x to sketch the graph. So in this case, it's given to you, the original graph. But if this wasn't given to you, you could have taken your original, your transform graph and remove C, remove the H, remove the D, and you were left with, let's say, I would remove this, move a negative, move 2. Left with y is equal to 2 to the x. So that's a way of finding it. But here in this question here, they give it to you. So it was, you didn't have to worry about figuring that out. But we'll show you how to get this done again. And again, we follow the same process as the previous one, except in this case, we are looking at no vertical translation, a horizontal translation, but also a reflection. So we have a reflection going on here. So let's look at how this will work. So now, for this graph, we have, so if we were to transform this, we have y is equal to 3. Now, I like to put this in bracket here. Put this as 2, negative 1, x minus 2. The reason for doing that, I'm making it similar to my y minus k is equal to c a. And remember, we have d x minus h. By doing that now, I can identify my c, my k, my h, and my d. So from here, I know can get my c. C is equal to 3. Now my a, in this case, I already know it's 2, so I'll replace that. It's 2 here. my d is equal to -1. By the way, you may ask, how did I arrive at this? I just factor out the negative here. I have what we have here. We have negative x plus 2. By factor out -1, it's become x minus 2, because negative x and positive. That's by factoring out my -1. Next, my k here is 0. I have nothing here, so I'll put k. Just as a placeholder, I'll put k equals 0 here, because my h now is equal to 2. Now, remember, if we have y is equal to 2 to the x, my image of that would be x over d plus h. This would be my new x coordinate point. If my x and the y here, and my y coordinates would be c y plus k, using this here. So I'm going to rewrite that. Y minus k equals c 2 t into x minus h. And our equation is y minus 0 is equal to 3 to minus 1 x minus 2. Now I know my x from here and my y from here, and then I just substitute my values for d and k. Now k is 0, so I can simplify this as x over d plus h and cy. And this is how you'll find your x and y coordinates for your transformation of your function, and we'll sketch it. So I went ahead and construct my table here. So I simply transform these into a chart to make my work look easier. So here is my equation, y equal to 3, 2 to the negative, open bracket, x minus 2. And I know, and I'll just write here beside here, my k equals 0, c. I'm just rewriting what I have at the top here, so I can readily t equals -1 and h is equal to 2. Okay, so basically we have, from our equation, we can tell right away we have a vertical stretch of 3, because it's your vertical stretch. We have a horizontal translation of 2. And we have a reflection on the x-axis. Sorry, on the y-axis. So let's look at how that will shape out. So we have like t 2 to the x is correspond to minus x plus 2. Now, here we have x over d. Now, x over -1 plus h, which is 2. C is 3 plus k is 0. Simplify this, we have x over -1, we give negative x plus 2. And it's 3y. So this will give us our x and y coordinates for our transform function. But first, let's find our y coordinates for our y equal 2 to the x. Then we'll sketch, and then we'll look at our transform graph. Then x is 2, y is 2 to the negative 2, which is equal to 1/4. So negative 2 is here. Then we have negative 1, 2 to the negative 1, which is a half. Two to 0 is 1. Oops. Okay, let's get this a little bit more precise here. Here's 1, so it should be, oops. So this would be 1 here. X is 1, so y is 2 to the power 1 is 2. X is 1, y is 2. Then we have 2 to the power 2 is 4, so 2, 4. Then we have 2 to the power 3 will give us 8. So x is 3, y is 8. So this is my graph. Now we can go one more, maybe make it 4. Or maybe one more. We'll go one more. You don't need to, but that's a little bit of fun. I'll give us 16. So 4, 16 should be up here. X is 4, y is 16, so I can connect. So this is my graph. Y is equal to 2 to the power x. Now, you can use this as your base graph to have a transformation. Now you have a horizontal translation, and we made it much simpler for ourselves. Look at this here. Horizontal translation 2 units to the right. So we know this will be shifted 2 units to the right. But also there is a reflection and a compression. So it will be a reflection of this graph. So I can tell right now it will be decreasing because it's going to be a reflection of it. Let's see if that works out to be the case. So now let's find our coordinates for our transform graph. Now we have x as negative 2. And we'll have negative 2, negative, so we have, oops. We have negative 2, maybe negative 2 here. So you have negative 2 times negative. It's not working out what I want it to be. Negative 2. Negative 2 plus 2, and that will give me 4. And then we have 3y, which is 3 times a quarter. Three times a quarter, and that would give us 0.75. So x is 4, and y is 0.75 will be right here. So first point, or approximately, I should say, not right there, but I'm approximating it. Now, x is -1, so we have -1 plus 2. So we have 1 plus 2 give me 3. Then we have x as a half, so we have 3 multiplied by a half, and that will give us what, 1.5. So x is 3, 1.5 is about there. We have 0 plus 2 will give us 2. And our y is 1, so we have 3 times 1 will give us 3. So x is 2, y is 3. X is 2, y is 3 up here. Continue. We have x is 1, 1 plus 2 give me 3. Then we have 3 times 2 gives us 6. Is it correct? Let's see. X is 1. So we have -1. Oops. It's not correct. -1 plus 2 gives you 1. Give us, and that's 3 times 2 is 6. X is 1, y is 6. Now we have x is -2 plus 2, we have 0. And then we have 3 times 4. Oh, no, 3 times, yeah, 3 times 4 is 12. X is 0, y is 12. Let's try and connect these points here so I wouldn't get lost. If we continue, we have -3 plus 2 is -1. And we have 3 times 8, which is 24. -1, 24. So -1, oh, way up here. So my graph is, sketch this graph. Now, the last one is way off my scale, but I will just continue with -4 plus 2 gives me -2. And maybe 16 times 3, which gives me 48. Now, my graph doesn't go that far. So we can conclude, here we have from our function, a transform function, we have a reflection above the y-axis. This is reflecting. And we have a vertical stretch of 3 and a horizontal translation of 2. And that will give us this graph here, y is equal to 3, 2, minus x plus 2. The question asks us, is the function increasing or decreasing? Now, this is a function here. I might as well highlight it with a yellow highlighter. So we can tell right away from that it's decreasing. This function is decreasing. Secondly, they ask us, the the intercepts. If you look at this graph, the graph has a y-intercept here at 12. Zero, 12. There's no x-intercepts. Horizontal asymptote is at where y is equal to 0, because it goes closer and closer to the x-axis but never touch it. Y equals 0. And finally, our domain and range. Our domain will be all the real numbers. And the range, y is greater than 0. I'll look at one last example for today, and it's found in your example booklet. And I'm referring to, now I haven't covered any of the e to the x. So if you look at your chapter 5 work booklet, and this is what you have to hand in for assignments. So if you go to question, by the way, just an editorial here, you need to change this where x is going to be between, where a is between 1 and 0. Because it's not complete, just to make a correction there. But let's look at an e to the x one, and it tells you here, we use e to the x, or the e, of which occurs frequently in math. And the e, as common name after Euler, as a wonderful mathematician, it is a fixed value. And this natural log is used throughout science and engineering. So just so you've become familiar with this here, y equal to, so the e is this wonderful irrational number, 2.71882818828. It goes on forever. It's like pi, which is 3.14159, goes on forever. You want to sketch this graph. So basically, if you can transform that number, which is y is equal to 2.7182881 to the power of x. The previous example will be, we had like 3 to the x or 4 to the x, is similar. If you want to create a table of values for this, and do a wonderful table of values, and this will be an approximation where we have our x and our y is equal to e to the x, which is basically 2.71. I'm just approximating it here to the x. So whatever value you choose for x, in this case, I'm just going to select -2. So this would be 2.71, and I'm approximating it to -2, which worked out to be 2.71 to the power of 2. Then we have -1, 2.71 to -1. We have 0. 2.71 to the power of 0 is 1. 1. 2.71 to the power of 1. And 2.71 to the power of 2, approximately 7.74. And we go ahead and sketch your graph. We have 1, 1, -1. So our graph basically be 1, 2.71, which is 2 here. The function is always increasing. The intercept 0, 1, which is your equation asymptote y is equal to 0. Domain is real numbers, and the range y is greater than 0. Just a reminder about this one here. So anytime you have an e to the x graph, you substitute the values given, and you'll end up with an exponential function.